Hello, class. This is the lecture for chapter 3 of the C++. Okay, sorry about that. I had to change. I had the old 8th edition slides open. So we have quite a collection of slides in front of us, so we'll go ahead and start. They're numerous for this chapter as well. So we're going to be going over a control flow in this chapter. And so kind of the subtopics here using Boolean expressions, Boolean being either true or false, expressions that evaluate true or false. Multi-way branches, ways of selecting logic based on input. More C++ loop statements, and kind of a high-level design, the thought of design behind these loops. All right, so control flow, this is the order in which statements are executed. And we've seen if-else, we've seen while and do-while loops as well. We have a couple of new constructs here. We have switch, and we also have for loops. All right, so we'll go ahead and start here with subchapter 3.1, Boolean expressions. Like I said, Boolean expression is an expression that evaluates to true or false. This comes from Sir George Boole, who was a 19th century English mathematician and logician. So Boolean expressions generally are going to be evaluated with either equal or some sort of inequality, less than, greater than, less than or equal to, greater than or equal to, and they will result in a Boolean value. In other words, true or false. Now, you do have some Boolean operations. You have the and, the logical and, the logical or, and the logical not, which we've also seen. Okay. Oh, yeah, also, yes, of course, Boolean variables will carry values of either true or false. Okay. All right, and we've seen the truth table. We've seen the order of precedence, operator precedence. For example, we have here y less than 3 or y is greater than 7. We also have the logical not of that. So remember the acronym PEMDAS. Of course, we're going to evaluate what's in parentheses first. So here, if y is 8, this evaluates to false, right? 8 is not less than 3. Now 8 is greater than 7. Now you see we have another nested parentheses over here, so that's going to be evaluated next. 8 is greater than 7, so this is true. Now here, we evaluate these two together, and we say false or true. Well, if either one of these evaluate to true, we know that this statement here, false or true, is going to evaluate to true. So we have true, and then we have the negation operator here. We have not true. So, yep, here you go, false. Not false or true, not true, and again in the order I kind of called them out earlier, and then false. So stare at that, look at the book, look at the order of operations, and you should get this. Okay, operator precedence. Yes, the unary operators, such as the negation, logical negation operator, will come first, and then relational operators, less than, greater than, less than or equal to, greater than or equal to, and then you'll perform your logic operators after that. So that's your order of precedence. And this will kind of become second nature to you. And it's really easy to force order evaluation with parentheses as well. All right. So yeah, of course, higher precedence operators are, operations are performed first. And then really the thing to keep in mind after that is that we're going left to right. Unary come before binary, as I said. Yeah, here's some more examples. So what we got here, you see the logical groupings. We have a binary expression. We have our our logic operator, and so you see we can kind of think of them as being grouped on both sides. And yes, this is because these operators have higher precedence than the logic the logical operators. And yeah, it's the same thing as x plus 1 greater than 2, logical or x plus 1 is less than -3. And do you see why? It's because this stuff here and this stuff here already has higher precedence than the or. So it's going to evaluate them in that order separately, and then it will or them. Yep. So, like I said, unary operators come first. Yes, and then you perform the order of operations as we saw them earlier, and they are right here. Short circuiting. All right, so sometimes you don't have to completely evaluate a Boolean expression. So let's say we're given the example here if x is negative. We can say, all right, so if x is negative, we know this much is not true. We know x is not greater than or equal to 0. Now what we see here is that this is false. Then we have a logical and. And with the logical and, both sides of the expression, this side and this side, both have to evaluate true for the expression to be true. In other words, if one side is false, then the expression, we know the expression isn't going to be not true. Now, since x is negative, this side's false, we can stop evaluating. It saves us time. We can stop right there. Okay, so that's a short circuit evaluation. And we can, yeah, this is exception prevention via logic here. So if the value of kids is 0, then you see the kind of logic error we are preventing. We cannot have a division by 0. Division by 0 is undefined. Okay, so kids is greater than 0, and so you see why we have this here. We have if kids is greater than 0, so that we do not have a runtime error and the program won't halt. And yes, integers, basically, they are, Booleans are simply their integers. Okay, a Boolean true is an alias, kind of an alias if you want to think of it that way, for an integer 0. Or excuse me, integer 1, and false is kind of an alias for a Boolean 0. It's basically defined as, if you look in the type defs in the headers, in the C++ headers, you'll see that true is a 1 and false is a 0 integer. All right. Okay, so some problems with the logical negation operator. So you see the example we're given here, the expression not time, the reverse of time is greater than limit. Okay, so if limit is 60, okay, since the unary operator comes first, we can kind of look at it being evaluated this way. We know that not time is going to be evaluated first. Okay, so if time is an int with value 36, what is not time? Well, okay, any non-zero value is true. Any non-zero value is treated as true. All right, so if time is an int with value 36, what is not time? Okay, so then false. There you go, or 0 since it will be compared to an integer. The overall expression is false. And yeah, it looks like there was a mistake there. Generally you won't see anything like this. You won't see an integer. You won't see a negation of an integer. Just know that a non-zero value is true. Okay. And so that not true will evaluate false, of course, which is 0. And 0 is not greater than limit, which is 60, so you have overall evaluation of false. And yeah, you see the intent was probably, that was probably a little error here. That was probably the intent to do this, not time greater than limit, because time greater than limit will evaluate to a Boolean, and it makes more sense to negate a Boolean, or to, kind of logically negate a Boolean. All right. So yeah, be sparing with the not, okay? It's a little confusing. It's a little hard to read. Again, readability and maintenance are highly underrated. So just keep your code simple. Don't try to show them how intelligent you are. All right, enum types. We're not too worried about enum types. They're just basically lists that correspond to integer values, either in incrementing order or the order you specify. All right, so multi-way branches. Okay, so if else, of course, is the basic branch that we've seen. And what we mean by branch is, a branch of code is a selection of code that can be executed depending on some sort of decision that is made. And you can have nested branches as well. If else can include another if else. I can come in here and say, if int equals 5. If I is greater than 2, which it is, if I is greater than 3, now here, let's say this, I is greater than 4, see out, I is greater than 4. All right. Then, you know what, here, how about this? Better yet. All right. So here's what I've done here. Okay, so I say if I is greater than 2, then if also I is greater than 4, then I'll go ahead and display, hey, I is greater than 4. Or else, if it's not greater than 4, I already know that it's greater than 2. You see what I've done here? And I've tried to make this readable by indenting. See, if I did this, then we'll be able to understand what's going on here. So what I do is indent my code. I say, okay, we are within this if block, so I'm going to go ahead and indent everything within this if block. Ooh, this cout statement is also within this if block, this nested if block, right? Okay, then this else corresponds to this if, so it's going to be at the same indentation level. And this cout can be considered to be a consequence of this else, so it's going to be, I'm going to need to indent it to show that it kind of belongs to this else here. All right, so here's an example. This is an example of a nested if. If, and I have my nested if and my nested else. Okay, or what I can do is come down here. This else will correspond to this first if. So I'll say else I is not greater than 2. I'll just say I is less than. How about that? I is less than or equal to 2. All right, so this is an example of nested if statements. And we can go ahead and run this. So I have, here, I'll say it's going to be 3 for clarity. So I would expect if I is greater than 2, it does. I would not expect to see this greater than 4. I would expect to see this greater than 2. I would not expect to see this less than or equal to 2. So we should see I is greater than 2. Let's make sure that there is nothing I'm not taking into account here. Yeah, I didn't give it enough time. Yeah, I had greater than 2. So this is a nested if. Now, for clarity, you notice what I should have done. You may be scratching your head there, and this is why. Actually, this else corresponds to this if. I kind of had it a little bit confusing there. And this is why I should have put this if in brackets. I'm going to do the same here. If, else. Now, you don't really, when you do brackets with this statement, with this and else, with any kind of control statement, if you only have one line, you don't really have to worry too much about, putting the brackets there. They're not necessary, and they're not going to improve readability that much. However, if you have them backing up to each other like I do here, you may want to consider it. Okay, it's just going to be a little more readable than this right here. You have a whole cluster of stuff here. All right. Yeah, if, that's a yes. Okay, so we'll continue. Yep, like I said, you want to indent each level. If you don't indent each level, you will get lost. The people that come behind you will get lost. All right. Yeah, be careful when you nest if else statements. There are a few pitfalls. Matter of fact, to give us an example, if the fuel gauge is below 3/4, then keep going. If it's below 1/4, then issue a warning. Otherwise, and this otherwise, this else corresponds to this top if, output a statement saying don't stop. So you see the logic there. Okay, if we're less than 0.75, and if we're less than 0.25, see out fuel very low caution. Else, and here's the pitfall right here. So if we're less than 3/4, you see this if, this is all one if block. Up here, we have this if, and this else corresponds to this if. So the problem right here is, if the fuel gauge is less than 3/4, print fuel over 3/4, don't stop now. So just be careful with nested ifs. Make sure you look at it and you understand what you're doing before you just go ahead and leave them and say, this is correct. You want to test all of your loops, but just take care. All right. So yeah, braces, of course, are like parentheses and arithmetic expressions. We've seen this. Multi-way if else. So yeah, if else is two-way. Now you can have multi-way statements as well, and we'll see this here. Okay, so you can have, well, here we have an example of guessing game. So if our guess is higher than the number, we'll say too high. If it's lower, we'll tell them too low. Else, we'll go ahead and issue a statement saying that this is a correct guess. So here you see we have a three-way statement. This is more than just a single if else. So you have alternative. You see instead of if, then else, then if, else, if. So you see how we're kind of sliding down here, and we keep indenting. You do have else if. You can just use else if. This is maybe a little bit clearer. Okay. Now, if you're only using ifs and else ifs, sometimes your condition may not match. Then nothing will be displayed out in that case. So sometimes you want to have a catch-all. Okay, so they gave the example here. We know that one of three conditions will hold. We know that either our guess will be higher than our number, it'll be less than our number, or it'll be equal than our number, or it'll be equal to our number. Excuse me. So if this is the case, if the guess is equal to the number, hey, we can get rid of this here, right? We don't have to say if guess is equal to the number. It's just kind of a waste of computation time and a waste of code. So we don't even need to have if guess is equal to the number right there, because if it's not higher and it's not lower, it's got to be the number. All right, and then this is, we just saw this above. This is basically just kind of showing us the pattern. If the statement to be compared, then go ahead and execute it. Else, if that wasn't true, then go ahead and compare this statement. Go ahead and execute it if this expression here is true, and so forth. And so you can have, our else, our last all encompassing else block that would catch everything else that doesn't match if none of these evaluates true. All right, here we have an example for a state income tax. All right, so computes tax according to the rate schedule. No tax on the first $15,000, 5%, from $15,001 or anything over $15,000 to $25,000, 10% tax on each dollar over $2,500. Yeah, this is a good example of if-else logic. So we can go ahead and do this if we want. If all right, so let's see here. No tax on first $15,000 of income, 5 tax from $15,000 to $25,000, $10,000 or $10 tax, 10% tax on each dollar over $25,000. So yeah, we can say what we can do is check for less than $15,000, and we'll say hey, no tax. Then we'll check for $15,000, anything over $15,000 and less than $25,000, and we'll go ahead and calculate the 5% tax and display that. Or else we'll check, if neither of those match, then we know that will be over $25,000, in which case we'll calculate 10% tax. So first, where am I? All right, first we'll say if less than $15,000, right? Or else, what was it? 15,000. Our salary is greater than 15,000, and salary less than 25,000. Then our tax is 5%, right? See how tax equals 0.05 times salary. Now, I could say if salary greater than or equal to 25,000, although I don't need to do that, because the salary is not less than 15 and it's not between 15 and 25, then salary is greater than 25,000. All right, and what do we make our salary? 20,000. So if that's the case, I would expect 20,000 times 0.05, which would be 1,000. So this program should display tax equals 1,000. Yep, there we go. All right, so you see, I got my if. If that doesn't match, I got my else if. If nothing else matches, I have my catch-all else. All right. That's true. They've got a good point here. The second line, you see, and I did this too. This is what I put here. If salary is greater than 15 and less than 25. Okay. This can be replaced with if income is less than 25,000. Do you see why? Because if income is less than $15,000, I already captured this. It's going to execute this statement, then exit the control. In other words, if salary is less than $15,000, it'll execute this, and then it won't worry about this stuff. It won't worry about this stuff. So I could do this, and it will give me the same result no matter what the input is. Okay, I just did this for clarity and because it seemed more intuitive to me. All right, switch. Now the switch statement's a good one. Many times you don't want to write so many else ifs. You can't do it. So what we can do, and I'll just give you a real quick example here, and we don't even have to have anything really concrete. What we can say here is char ch equals D. Just a moment, sorry. Okay, sorry. So let's say we have a character, okay? Let's say I want to execute, I can execute 26, well, really more than that, a whole heck of a lot more than that. Any number of statements based on the value of this character. This doesn't really, if, else doesn't really seem appropriate. What I'd like to have is just kind of one line, or maybe even multiple lines of code, depending on the value for this thing. So what I could do is use a switch statement instead of a multi-way statement. So let's see here. What we can do, we can say switch on the value for that character. Okay, switch will require braces. Okay, case A. Okay, so what I do here, I'll put each one of my cases. In case the value of that character, CH is A, then hey, the value is A. And I'll have to break. So this is important also. And then I'll put my next case statement. But notice that I have to break with each case statement. If I don't break, actually we'll see an example of not breaking. Then I'll put my next case here. See out. Value is B. And we'll just put a few of these. And we'll put one more for good measure. All right. So what I have here, I have my character value. The value for my character is D. So I would expect to see the value is D displayed here with this program. We'll compile and link. All right, and let's run. And survey says, yeah, the value is D. All right, now this is a big pitfall. I do it all the time myself. If you forget a break, or two, or all of them, you can have side effects. Ruh-roh. You see what happened here? Even though my value is D, it does not equal E. If I don't put a break here, it will follow through to the next statement. Be careful. Got to put your breaks there after each case in a switch statement. Oh yeah, so we can also have a default, you know, as I think about it, that's a good point. Then here, if we can have a default case, if nothing else is matched. If I can spell, we can anyways. All right, and I'll change my value. Actually, I change my value to equal, you know, T, or some sort of a value that we know is going to be unrecognized. There we go. I don't know what the value is. So in other words, since no other case matched, we went to the default. We fell through to the default. So that's a case statement, or switch statement rather. And we've seen this, you know, switch based on, you know, whatever value you want to switch on. Case, and then, you know, the constant value that we will compare to our expression. So if that case matches, we execute any sequence of statements, and then we need to break out of that switch statement. Otherwise, remember, we'll fall through, and we can have a default value at the end if none of our other values match. All right. Yeah, so the controlling statement can only be bool, enum, integer, or char. Yep. Again, when a match is found, you use the code for that case. Be sure to put the break there so that it doesn't fall through to the code for the next case. Okay. The break, yeah, it will end and exit that switch statement. And yeah, this is a good point here. So this is the same example we had earlier. You know, if you give it a capital A, in this example, you won't execute any code for the capital A. However, you'll fall through to lowercase a, and you know, excellent will be displayed. And we saw the default. If none of the other cases match, then we'll fall through to the default. Yeah, this is true. Nested if-elses are more versatile than a switch statement, but sometimes switch statement can be a lot neater than having a whole lot of nested ifs and elses. So what they're trying to say here is that if you have an if or an else that's going to require multiple statements, a whole lot of statements, instead of having big blocks in your ifs and your elses, it may be handy just to call an auxiliary function. So this may help keep things neat and organized. That way you don't have big monolithic blocks of code. So yeah, each branch of a switch or an if-else is going to be a separate task. And again, use judgment here. So, you know, where we said earlier, if you have multiple statements, go ahead, you know, you can call an auxiliary function to do the work for you. You know, again, on the flip side, if it's not a whole lot of work inside the branch, then you don't want to call a whole new function. You just want to go ahead and put code between braces. Okay, so use your judgment there. All right, and code between braces is considered to be a block. So a block, you have the concept of scope when we talk about blocks. Variables that are declared inside of blocks only have visibility inside that block. In other words, if you try to reference a variable outside of a block of code in which has been declared, that's an error. So statement block is just a way of nesting statements together. Well, not really nesting, more like grouping statements together. And you can nest blocks. This is true. And now, if you nest blocks, just be careful. It can make it a little unreadable. You need to know what you're doing when you do this. And yes, this is true. you may want to nest. You may want to create function calls instead of nesting blocks. It can get things can get ugly. So just remember readability, and you may need to refactor your code because readability is kind of key. You don't want to have huge blocks and blocks within blocks of code. You want to keep everything succinct and concise. All right, so going further about scope, if we have a variable, now if we have a variable in 2 blocks, now let's say we have a block and we have a block inside of a block. These are going to be 2 different variables. Okay, let me show an example here before we go any further. All right, so I got an integer declared here inside this if statement here. Okay, so I have an error. What's my error? I undeclared first used. Okay, so really the compiler is griping at me here because I declared I within this block here, the block for the if statement. Therefore, it doesn't exist out here. You know, its scope where it lives is only within the block in which it's declared. Okay. Now what I can do, watch this. Okay, I'll do something like this, and int I equals 0. Well, I got 2 I declarations. Is that a problem? Let's see. We'll compile. Nope, not a problem at all. Remember, this variable only lives in this block here. So therefore, out here, there does not already exist any integer I. It's not going to give me warning about, you know, reinitializing or any kind of error. Okay, and so when we display this I would expect to see 0 displayed on the screen and not 1. There we go. All right, and so this is going to be something that you should do by yourself. It's not anything that we need to figure out here. So that's an exercise for you. So more about loop statements. All right. Okay, so loop will execute a section of code a certain number of times. So we have a body, and then we have our loop declaration. So, you know, inside the body, we're going to have all of our statements that we will execute, and that we will run, and that we will repeat. Okay. And so, yeah, when we design it, we have to keep in mind, you know, how many times does this loop need to iterate, and what is it going to do inside of it? So remember a do while loop. That do part will always make the loop execute at least once. Doesn't matter whether the Boolean is true or not, because the Boolean comes after in the while part. We have seen the increment operator. There are a few ways of incrementing in C++. Okay, so we'll start, you know, we'll give an example of an integer I that equals 0. We can say I equals I plus 1. That much is pretty intuitive. We take 1, we add it to I, which equals 0, and we store the result in I. So now I equals 1. All right. Now what we can also do, remember we saw plus equals? So that's a shortcut operator, and basically that means just add 1 to the value of I and put it back into I. So now I would expect to see 2. And even shorter, I plus plus. That's where C++ gets its little cute name from. All I++ does is add 1 to I. So I would expect this to equal 3. Now what we can do, we can also say plus I, because this is the postfix increment operator and this is the prefix increment operator. Now there won't be any difference here. I would expect to see 1, 2, 3, 4. Let's make sure that we're on the same page here. Yeah, 1, 2, 3, 4. Good. Now there's a difference between the postfix and the prefix increment operator. So now let's see what we got. So what I have here, we know that I equals 4 at this point. So what I'm doing is I'm assigning the value of I++ to j. So will j be 4? Will j be 5? Will k be 5 or will k be 6? Because I'm adding 1 to I and assigning the value to k. Take a look at this for a sec. Put me on pause if you need. Think about it. J equals 4, k equals 6. So yeah, all right, good. So you see what happened here. Int j equals I++. So when we postfix increments, we assign the value of I to j. Then we increment it. This is why it's postfix. You know, it will increment afterwards. Now, at this point, k equals 5 and I equals 5 after this executes. So then plus I, you notice that j equals 5, we add 1 to j, we prefix, rather, we prefix, we go ahead and increment I, and then we assign the value to k. So then, in this case, k equals 6. In fact, we even have, I think, an example in the PowerPoint here. Yeah, so we have int number equals 2, value produced equals 2 times number plus plus. Well, this is going to do the same thing. This is going to multiply number by 2 and store the value in value produced, and then it will increment. And see, this is what we just did here. So number plus plus will assign the value number before it increments, and this will increment before it does anything. That's the difference between postfix and prefix. And, you know, I give you the example of, you know, plus plus. We can also change this to minus, because we can use this, you know, as a decrement operator. This will compile and run just fine. Same principles. Also, hold on, let's go here. Yep, decrement operator, same. All right, for loops, for loops, for loops. Okay, this is one of the more important constructs. So what a for loop does for loop does the same job as really any other loop. Just does it differently. You know, we had our while loop, which is going to execute as long as the Boolean condition within the, you know, the while is true. We have our do while, which will execute at least once and then continue to execute until the condition in the while is not true. Now, what for does, for will give you a counter. Actually, you provide the counter. So here I have an integer that I initialize to 0. here is my stop value. So I initialize my integer I at 0. I say, as long as I is less than 99, go ahead and do this junk in the loop. Then after the loop is done, increment I. So if you look at this, I equals 0. As long as I is less than 99, go ahead and do stuff and increment I by 1 each time you're done with the loop. So how many times do you think this loop will execute? 99, right? Because we start at 0, then I is incremented to 1, I is incremented to 2, et cetera, until I gets to 98, then the loop doesn't execute anymore. So if I wanted this loop to execute 100 times, what might I do? I could do this, right? Because then we go 0, 1, 2, 3, 4, blah, 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 up to 99. So we'd have 0, and then we have 1 to 99, which is 100. Or I could even do this, right? 1 to 100. You know what, we'll scale this back to 10, and we'll let her rip. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, good. And so yeah, to prove that I was telling the truth before, we'll go ahead and execute this. This should execute 10 times. Now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. And if I were to do this, what would you expect? 9 times, right? You just have 0 and then 1 to 8. Yep, so you'd execute it one last time. So that's a for loop. Your initialization, your kind of stop condition, if you will, or while this is true, keep executing, if you want to think of it that way, and then your, increment, decrement, whatever. This doesn't have to be an increment. It can be a decrement. It can, you can multiply. Any expression is valid. For loops are very useful for adding, multiplying. Also, they're useful on arrays, which we'll see in a little bit. So here's an example. If you want to sum the numbers 1 through 10, which should be, I think, 50, we can say, while, one way of doing it with a while loop is, say while n is less than or equal to 10, go ahead and add n to the sum and increment n. Another way of doing it is saying, hey, for integers between integers between 1 and 10, go ahead and add to the sum. Should give us 50. We'll go ahead and do it. For I is less than, here. 1, I is less than or equal to 10, right? This will add 1 through 10. I'll go ahead and declare an int named sum plus equals I. Then we're done. We'll say what the value of I is. It should be 50, I think. So that's what we plan meaning at 1. Line 6. 1, 2, 3, 4, 5, 6. Just a moment. Oh, actually, I see what I did right here. What we'll need to do, you see what I did wrong, see why it's complaining. I declared this integer I in this scope here in this for block. So what I'll need to do, I can just declare I up here. That'll solve that problem because now I have the scope of this outer block from here on down to here. Just a moment. Okay, sorry, I'm back. Oh, I'm seeing. Okay, so anyways, that was good. That was good. You see what I did here? See how I gave me 11. So this shows you that at the end of each loop, it will increment our counter. So when we got down here, we said, okay, I equals 10. We added 1 to I, and I equaled 11. Then it said, oh, don't execute anymore because I is not less than or equal to 10. And so that's why we saw I there. Here we go. So that'll do it. There we go. Okay, 55. All right, sorry. My mental math was off. So yeah, remember we have our initialization, our expression to evaluate as to whether, we should keep going in the loop or not, and then our update. And yeah, you can also, like as I showed you, you can use the declaration here in the initial, in the initialization, or you can declare the variable above it. I prefer to do it in the initialization here. That way it's just one less line of code. And yeah, it doesn't have to be, as I said, it doesn't have to be a straight up increment or decrement. You can, you can say n equals n plus 2 or n plus equals 2, n equals n minus 7, n minus equals 7. You can put any valid statement in there that will operate on your, your counter variable. And here we have a little more complicated expression. So for, we're declaring a double that is equal to y to the third. We'll say as long as, x is greater than 2, go ahead and continue in the loop. And our update action is to make x be equal to the square root of itself. And yes, just as in other loops, if you have one statement executing the loop, you don't need braces. If you do, then if it's more than one statement, then you're going to need braces. All right, so this is a good point here, the empty statement. Be careful. This is what they're getting at. If you put a semicolon after a loop initialization, it will treat the semicolon as a statement, and it will stop the loop right here. This cout hello will be executed outside of the loop. Don't put a semicolon directly after the loop initialization, or that will happen. Okay, it'll end the loop immediately. Yes, so be careful. Be careful here. The discussion about ANSIC, variable declared in the for loop initialization needs to be local to the block of the for loop. And we saw this with my compiler here. We saw this with MinGW. I is not scoped out here. Remember, I did cout I and I didn't recognize I because I was local to this block. So just be aware, be compiler aware, okay? Which loop to use? This is A, a personal decision, B, kind of your judgment call to make as to what's best for the situation at hand. Whether you should use a switch, a while, a do while, a for loop. I really like for loops where possible. They're not always possible. Sometimes, I'll want a while because I want to execute something as long as a variable is true or as long as a certain condition is true. Okay, so this is a judgment call you'll need to make. Experience will help you, but now that you know the different loop types, you really should be able to make the decision yourself at this point. Yeah, for loops, as I said, are useful for calculations such as summations and multiplications, and in particular with arrays or other data structures, as we will see in the future. Okay, and this is what I said about while loops. Sometimes you can't always use for loops. Do while, just remember that it's a while loop with at least one execution. Okay, the break, as we saw with the switch, the break will break you outside of that switch statement. When you're in a loop and you break outside of that loop. Okay, what I'll say is if I equals, I don't know, 2, break. All right, so look at this. I have inside my for loop, I have summation, and then I say, hey, if I happens to equal 2, go ahead and break. So what I would expect to see here, if this break does indeed get me out of the loop, I'll add 1 to sum, which would make sum 1, then I'll break. So I would expect this to output 1. Oh, I got 3. Oh, no. Yeah, that's right. That is right. Because I add 1 to sum. Okay. Then I increment my counter. I now equals 2. I is less than or equal to 10, so I'll continue. Now I'll add 2 to sum, and that'll equal 3. My sum equals 3, and I equals 2, so I break. Okay, so yes, break will break you outside of that control structure. It will break the execution. And yes, good point. When using nested loops, break will only exit the loop in which that break statement occurs. It won't break out of the outer loops. It'll only break out of that inner loop. So this is kind of your, this is yours to have at here. I can tell you something in series such as 1/2, 1/3, 1/4, 1/10. Just keep in mind we have, here's a hint, we have numbers that are incrementing up to a certain number. Okay, that should tell you what kind of loop we need to use there. List of exam scores. Okay, so yeah, these are pretty intuitive. You should have at these by yourself. So loop design, this is just kind of some hints about how to go about doing this. So again, we have to design the body, which is the statements that we're going to be executing, the initialization, and the conditions for ending of the loop. So yeah, you can input a list of numbers and you can add them, you can average them, perform standard deviation, whatever. So let's say we're adding. Given the example of, we'll create a sum variable that's initialized at 0, and we'll go ahead and read in a whole bunch of values and we'll add them to the sum. Okay. What we can do here, if we know how many things we want to add, we'll start and we'll execute as many times as we know we need to. Okay, that's pretty straightforward. Yeah, again, I said this many times. This is exactly what I said this many times. Okay, so for loop, yes, when you know how many iterations you want to perform, that's what a for loop is. That's its strength. Okay, and you don't have to add necessarily inside a for loop. You can perform really anything, any kind of valid statements you can perform. Here's an example of product. Okay. Yeah, and note that they initialize product to 1 and not 0, which is common with loops. 1 simply because 0 times anything is 0, so it didn't matter how many times, doesn't matter how many times this loop will execute. If you start your product at 0, then your result's always going to be 0. So yeah, the ways to terminate a loop, list headed by size. Yeah, so this is for loop. We can tell it when we want it to stop. Yeah, that's what our the second part of our loop initialization is. Ask before iterating. So this is where we're looking for input from the user. Do you want to continue, yes or no? We can have a list ending with a sentinel value. So a sentinel value is, let's say we tell the user enter -1 to stop enter the next number to be summed or enter -1 to stop. So if the user enters -1, that is the sentinel value telling the program to stop execution there. Running out of input. So this is just when we're reading from text files generally, using the end of file function to indicate the end of the file. So there's a particular end of file character, 25 hex is going to indicate the end of a file. So when we're at the end of our input, that's when a loop can stop also. And we'll see, I/O in chapter 6, I believe. So for list headed by size, again, this is where we give it input that tells it how many times to execute. That's basically, kind of our max counter. Again, it doesn't, we can say count is less than or equal to items. We could even have count is greater than or equal to items if we're decrementing. Any valid expression will work here. Ask before iterating. Yeah, like I said, yes, no. Okay. A list ended with a sentinel value. Yeah, like I said, place a negative integer after the list is exactly what I said. Enter a -1 to quit. Okay. And in this case, the number wouldn't be greater than 0, so the loop would stop executing. Running out of input. Yeah, here we have the example of a text file that's open and read from. As soon as this end of file character is read, that's all this is saying, then we'll stop. So high level, we have, count controlled loops, which is a for loop. Ask before iterating, do you want to continue? Yes, no. Exit on flag condition. A flag will be, while or, a certain sentinel value. Count control, again, for. So yeah, flag condition. Like I said, sentinel value or end of file. Here's an example of a flag. It says flag caution. This should say flag condition, actually. So, in this case, the condition is if a grade is 90 or greater. Because really all this loop is doing is looking to check whether a student has a grade of 90 or higher. And as soon as you have a grade that's 90 or higher, this loop will stop because this while is no longer true. And be careful, there's a little pitfall here. You see, might not stop at the end of the list. There's no student has a grade of 90 or higher. That's right. That loop, while loop would never finish. See why? If you don't have a grade of 90 or greater, it's just going to keep on asking for input. So what you might want to do is say, you might want to give it another limitation on the size of the class. Yeah, see, while grade is less than 90 and you're less than your total number of students. So as soon as you input the same number of grades as we have students in the class, then you can go ahead and quit. Nested loops. So that's a loop inside a loop. We can most definitely nest loops. This is very useful for, two-dimensional or multi-dimensional arrays, nested data structures. So what I can do is, I is a very popular counter variable name, and so is j. For int j equals here we'll say 5, j equals 1, j is less than or equal to 5, j plus plus. All right, we'll say okay, so you see I've got a loop inside a loop. So I have my outer loop, which is I, my inner loop, which is j. So my outer loop will execute 5 times, so will my inner loop. So inside my inner loop, I'm going to go ahead and say, hey, I equals blop, j equals blop, so that we can see the action in here. So my inner loop executes 5 times. Then we exit control from that inner loop, because when j equals 5 and this executes, then now j equals 6 and the next, now my Boolean condition no longer holds true here. So I'll go to the next iteration of the outer loop. Then I will equal 2, and I'll go through 5 iterations of the inner loop. Then I will equal 3, then I'll go through 5 iterations of the inner loop, etc. So let's take a look at this, and we'll see, so you can kind of get the feel for it, what happens here. All right, there we go. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So yeah, like I said, inner loop executes j times for each execution of the outer loop. Yep, when loops are nested, all iterations of the inner loop are executed for each iteration of the outer loop. This is what we just saw. Debugging loops. So yeah, infinite loops are a big, big problem. Many times you will switch less than for greater than or vice versa, or a criterion will never happen. Criterion will never happen, and you'll just keep executing. So that's going to be a logic error that you'll need to look at. And another common error is an off by 1 error. Sometimes you'll have less than instead of less than or equal to, or vice versa. You have greater than instead of greater than or equal to, or vice versa. Sometimes you can start at 0, your counter at 0 instead of 1, or vice versa. So those are going to be the most common causes of off by 1 errors. And yeah, see, should it be less than or equal to? Like I said, it's easy to switch these two up sometimes, or greater than or equal to. And yeah, look at your initialization value. Like I said, if it's off by 1 error, a lot of the times it'll be that 0 versus 1 or 1 versus 0 counter start problem. Infinite loops, yeah, like I said, many times it's easy to switch less than or greater than. So this is a good point. Test for less than or greater than rather than equality, because watch this. This might seem like a silly example, what we got here. What I want to do, I want to start at 0. Hey, as long as I isn't 5, because if I'm incrementing, eventually I'll hit 5, right? Well, if you look at this closely, I'm incrementing by 2, and so I skip over 5. I'd say 2, 4, 6, etc. So I should have an infinite loop here. Oh yeah, I got a big, long infinite loop. So that's an example of that logic error, and this is also an example of an infinite loop. So if you want to debug a loop, really the best way to do it, easiest, simplest way, let me say it that way, is to use cout statements at this point. Later on, you can learn to use debuggers and become proficient with debuggers, but cout statements are pretty good. So there's just an example here. And I see a couple of problems actually with this one here. Yeah, so I see a couple of problems here. And I think it's probably going to point these out in the next slides. But you see one problem if we want to get the product of 2 through 5 less than 5, so we won't hit 5. So this will multiply 2 through 4. And actually, you see, we increment next first. So really, we start out with next equal 2, and we have 3. Product equals 1 times 3, then 4, then 5. So yeah, you can use cout statements to go ahead and print out the value of these variables, and that way you can see what's going on inside that loop. So yeah, if you pay attention, those cout statements that they included could surely tell us. They could show us that the loop never, it never really multiplied by 2 because the next was out of order there. And then you could also see that after you refix, it won't multiply by 5 because of that less than, and see, we can turn less than to less than or equal. And yeah, every time it's changed, you have to recompile it, you have to retest it. Okay, you don't want to miss something simple because you didn't run it. And so you see here they have the boundary conditions outlined. So what you want to do, you want to at least run through no iterations to the loop body, 1 iteration, the max number of iterations -1, as well as the maximum number of iterations. Those are the boundary cases that we wish to test when we test loops. And yes, don't be afraid to throw it out. Start it over. If you go down a horrible road, don't try to patch something that can't be saved. Okay, you can just go ahead and start all over, and it's a lesson learned. And then these are going to be for you. We already discussed them. All right. So I hope you have a little better idea here about loops and Boolean conditions and control statements. Any questions, just ask. I'll see you at the next lecture.